Okay, number 3 here of our example. So we're going to graph and label this quadrilateral with these vertices. Let me make this a little smaller if I can. There you go. So it all kind of shows up. Sorry about that. So negative 9, 7. Here's my polygon tool. That's left 9, up 7, negative 9, 7. And then 6, 9. Where's it going? Negative 9, 7. Okay. All right. It's back. I don't know. It keeps disappearing. And then 6, 9. Okay, good. And then 8, negative 6. Good. And then negative 7, negative 8. Negative 7, negative 8. Nice. And there I go. And this is a little bit big, but I think that this looks like a square. I know it's kind of tilted. It might be hard for you to see, but I think it's going to be a square. So that'll be my choice. So then my goal is to prove that this thing is a square. So first of all, squares are parallelograms. So I have to show that it has 2 pairs of parallel sides. So time to do our slopes. Let's find the slope of AB. So here's A. To get to B, I need to go up 2 and right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and right 15. Goodness gracious. So that's a slope of 2 over 15. So down here, this is my slopes. So the slope of AB is equal to 2 divided by 15. And that does not simplify, so that's done. Let's find the slope of BC now. So to get from B to C, I have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So down 15 and right 2. So that's a slope of negative 15 over 2. So the slope of BC equals negative 15 divided by 2. And again, that does not simplify. Now, those are kind of interesting slopes, right? Maybe you're thinking about something right now. All right, let's find the slope of CD. I'm going to go from D to C, up 2, and then right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Up 2 and right 15. So that is a slope of CD of up 2 and right 15, 2 over 15. All right, there we go. Right, I got one matching slope. And now from A to D, let's go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and right 2. Down 15 and right 2. So the slope of AD equals down 15 and right 2. And from these slopes, I see that A, B, and C are the same. I see that B, C, and AD are the same. I have 2 pairs of parallel sides. So in my, again, this is, again, you could just type this out, but this is just me being, the teacher. So segment AB is going to be parallel to segment CD, and segment BC is going to be parallel to segment AD. Means we have 2 pairs of parallel sides. Okay, now we also want to look at the consecutive sides. So like A, B, and BC. Notice these slopes are 2 over 15 and 15 or negative 15 over 2. So 2 over 15 compared to negative 15 over 2. One's positive, one's negative, one's 2 over 15, one's 15 over 2. These are opposite reciprocals. That means your consecutive sides are perpendicular, which means you're going to have 4 right angles. So again, you can say this how you want to. I'm going to say it just like this. So this is going to be a little bit long too. So we're going to say that segment AB is perpendicular, in the symbols, perpendicular to segment BC, the consecutive sides. We're going to say segment BC is perpendicular to segment CD. We're going to say that segment CD is perpendicular to segment AD. And we're going to say that segment AD is perpendicular to segment AB. And this means that you have 4 right angles in your parallelogram, which means you're now a rectangle. So I'm a parallelogram that's a rectangle. So now I have to see if I'm going to be I'm going to see if I'm going to be a square. And for a square, I need to know if all 4 sides are congruent. And in fact, because I'm a parallelogram, I only need to show that one pair of sides are congruent. Same thing here. So like, let me take this back for a second. We only need to show that one of the angles is a right angle. So I'm going to say that because AB is perpendicular to, and again, you can say it how you want to, but I'm going to change this, give you a little bit less writing. Because that's true, we know, notice the arrow ahead, we know that angle, and again, I'm just trying to be fancy, angle ABC is a right angle, right? So if AB is perpendicular to BC, so AB perpendicular to BC, right here in my picture, if AB is perpendicular to BC, I know that's a right angle. And because it's a parallelogram, that means D is a right angle because opposite angles are congruent. And that means C and A are right angles because consecutive angles are supplementary. And if one of them is 90, the other one must be 90 to add up to 180. So you only need one right angle in a parallelogram, which is what we have. And because we have one right angle, we have 4 right angles. And now, like I said, I only have to show that 2 sides next to each other are congruent. And those 2 sides are going to be AB and BC. Let's see. So for AB, I'm going to do the square root of, and it was 2 squared plus 15 squared. That's going to be the square root of 229. And that does not simplify, so that's good. That's AB. And again, if you want to say these are the side lengths, you can do that. Now let's find BC side length. And again, it's going to be 15 and 2. Ignore the negative when you're doing length. So BC equals the square root of 15 squared plus 2 squared. And those are the exact same numbers inside the square root as AB. So of course, it's going to be the same thing, square root of 229. And what this shows is that AB is congruent to BC. Segment AB is congruent to segment BC. And because those 2 sides are congruent, right, if you look up here, so AB is congruent to BC, but this is a parallelogram. So AB is also congruent to DC, and BC is also congruent to AT. So now all 4 sides are congruent. So this has 4 right angles, and it has 4 congruent sides. It is, of course, a square. So down here, because those 2 consecutive sides are the same, and it's already a parallelogram, that means you have 4 congruent sides. That makes you a rhombus. If you're a rhombus and a rectangle, you are most definitely a square. Excellent. So there you go. So there's 3 good examples of what I want you to do. Again, down here, don't worry about the math type. Just type it out if you want to. Make sure your slopes are simplified, but then make sure you use those original slopes in the distance formula for your rise and run. All right, great job. Hopefully the homework goes okay. They're longer problems, but take your time, do them right, and make sure you get the graph right. Right, you are in bad shape if you can't graph correctly. All right, good luck.